All right, we're going to go ahead and get started. So if you read the tagline for today, we are going to agitate some substances. And so we're building on some of the stuff that we've been doing. And when we were playing around with the baking soda and the vinegar, we basically agitated a substance. And we created a very, very eruptive type situation. Today, we're not going to be eruptive, so if you were looking for glitz and glam today, not so much. But I did promise that this is something that you can do in your own kitchen. And I know I'm breaking a huge lab rule, and that would be that you can actually eat what you make today. So, what we're going to be doing is we're going to be playing around with this today. This is called heavy cream. Heavy cream. Now, if you guys have enjoyed two things, and I'm not going to tell you what those two things are yet. If you've enjoyed these two things, you have enjoyed heavy cream in its most wonderful state of matter. So, we need to kind of figure out, where did the heavy cream come from? Well, inside this container is, what do you think?
Milk powder.
It's milk. Yes. Now, yes. Now, if we could really have the coolest science lesson ever, we'd have a cow. I could milk the cow. We could get that milk. We could let it sit for a couple of days. And then we would get this really cool substance that's in here.
Called milk.
No. Heavy cream. Cream lifts to the top of the freshly squeezed milk, or the milk that comes from a cow. Cream lifts to the top. And that's because there's different densities between the actual milk substance and the cream. Okay? Now, if we go back to a little bit of what we've talked about before in regarding physical changes. Physical changes involve taking a substance, and we could just rip the paper and we still have paper. Okay? I could take the paper and I can crumple the paper and I still have paper. But today what we're going to be talking about revolves around this. Chemical change. Okay? When we apply a chemical change to a substance, we can't get that substance back again. The key word that we're going to use today is that we are going to apply some agitation. Okay? Agitation. Now, the first form of agitation is going to come in the form of the mixer. Okay? So what I'm going to do, I'm hoping that we can get the camera angled enough so that you can see my mixer, and you won't be able to see the actual process happening, although I'll see if I can adjust the camera enough for you to see that. So what I'm going to do is I'm going to take some heavy cream and I'm going to put it into my stand-up mixer, which is down there. I think you guys can see it now. And I'm going to apply some very basic agitation to this heavy cream. So it may get a little loud for a moment. But what I'm doing is I am applying some very, very light agitation to the cream. What's happening, and we're going to get a little bit high school level explanation here, is that we are beginning to kind of rough up the fat molecules inside of the cream. As we do that, we are going to create a brand new substance. I will no longer have the sloshy cream that I started with. And this particular process takes a few minutes depending on how fast I want it to get there. But there's a very fine line between what I'm going to do first and then what I'm going to show you second. Two different substances being made with the exact same compound, heavy cream. Now, if you can see inside of this, you can see that there would be a lot of bubbles that are being made, and the substance is beginning to thicken, and that's because we're agitating the fat molecules inside of the cream. So, the milk product that you drink is not this. The cream's been separated out, and there's a lot of chemistry that goes into that process before you get the milk that you enjoy with your cereal at breakfast. All right, I'm going to let that go for just a few minutes because I know from past experience that it does take a little bit of time. In this agitation process, what's occurring is that we're beginning to go through a process of taking this chemical formula. No, we're not going to go into great detail today because that would be more of your high school chemistry class. But just understand that this is the chemical process that we are working through. And that we want to separate out part of this, making that chemical change, and then we're going to get to this, which then molds into this. And I know we're getting complicated. Probably my favorite diagram, because we're also forcing water out of this. Okay? Moving on to water molecules being pushed out, the fats basically being agitated to the point that they're combining, and then we get the first substance. All right, now I'm going to see if I can actually show it to you. And so we are at Cool Whip stage. So what did I make? I made whipped cream. Now, if I leave it on there just a little bit longer, it will stiffen up just a little bit more, and we will have probably what you would consider your traditional whipped cream that you have probably had on strawberry shortcake or topped on top of brownies, or if you've had wonderful pretzel salad. Cool Whip, is one of those things. But Cool Whip's a slightly different combination than actual true whipping cream, which is what's inside this bowl right now. Okay, so I'm going to put it back on the mixer to see if I can tighten it up a little bit, and we're going to go to the next step. Now, as I said, we're working on chemical change, and we're focusing on this piece here, agitation. We're agitating the mixture. The longer I agitate the mixture, or the speed and the velocity I agitate the mixture, is going to change what substance I wind up with in the end. Now what I'm going to do is I'm going to use a special little mixing ball. Put inside this. I'm going to put the heavy cream inside of here. And this is the fun part. So if you happen to have a shaker like this at home, then you can get your workout in, and that would make PE really happy, and you get a really cool substance when we're done. So all I'm going to do is sit here and shake this. And in a few minutes, I don't know if y'all can hear the rattle. In a few minutes, the rattle's going to stop. And that's because I will have achieved the next substance that I want you all to see. Now, if any of you attended preschool in any of the local preschools, they did this lovely little thing with marbles instead of the little whipping tool that I have inside of this container. It takes a little bit longer to achieve that, to achieve what we're getting with the marbles. But the cool part is that in class, what we would do is I would take this and I would say, here you go. You get a turn to shake, you get a turn to shake, you get a turn to shake, and see who's the one that winds up with it when it stops moving. Now, you can probably start to hear that there's a change in the substance inside at this point. And yes, it does become harder and harder to make the ball inside of this, the mixing ball, continue to move. That tells me that the substance is beginning to change. And it's really cool when you have students to pass it to, because then I don't have to do all the work. So, if you guys want to follow along with me, and let's do some arm shakes to help me through this, because I know I've got probably about another minute before this is solid. So, grab something near you and help me shake. Please, thank you. All right, so the first substance I got a helper to help me continue shaking. So the first substance we made was the whipped cream, okay? And if it was in a nice pretty bowl, we'd be able to look at that. So the substance has a very nice, kind of still fluid type texture to it. What we're working towards, and I might achieve it in the other mixer first, is the other substance. And this is one of those times I wish I had time-lapse photography. The heavy cream is a substance that is inside of milk, okay? When you actually, if you were to milk a cow and the milk comes out, there is a substance that will come to the very top of the freshly squeezed milk, okay? Now, is it actually heavy cream? Yes, it could be considered that, but it is the cream of the milk. It is the very, very fatty part of the milk. And what we're doing as far as the chemical change that's occurring is we're taking all of the fat that is inside of that cream and we are agitating it to the point that we are causing it to smush together. Okay? As it's smushing together, all of the liquidy aspects, because fat's a solid. Fat is a solid. So, all of the liquid is being pushed out. So all of the water and any of what's left of the milk is being pushed out. And so what happens is that the slight agitation gets us the whipping cream or the whipped cream. The intense agitation takes us to the next level, and that is whipped butter. And so, yep, there we go, very stiff. So there's a little bit better diagram or a little bit better look at the whipped butter. So, applying just a little bit more agitation, and if you don't do it in the right, if you don't watch what you're doing, you can go from whipped cream, which is yummy and delicious on some strawberries, straight to butter for toast. And that's all with one substance. So, this is what it looks like when it's no longer all drippy. And if I take it and I agitate it a little bit more, it will thicken it up just a little bit. And then the next step, which this one, if we had time-lapse photography, and this will be part of the video that we'll post on Nearpod later, is that I'm going to take the substance and I'm going to smush it together. And when I do that with some cheesecloth, not my hands, some cheesecloth, and get that additional liquid out, I will have basically fat-free milk as the liquid, and then I will be able to make the butter like you would see in the containers. Because that's all I need is a few more minutes of whipping the substance to get us to that next stage. One substance, heavy whipping cream. And yes, you could get a hold of this. You don't have to get as big of a container as I did. And as I saw, Caitlin has one in her house. You don't have to have the fancy mixing container that I have. Okay, this is the milk. And I was going to show you that if I mix, this won't do anything except froth up. And that's what they do if they want, if you have ever had a cappuccino or, I think mostly cappuccino, maybe a latte. They agitate the milk a little bit to give you that nice pretty froth that goes on top. The butter, this is what we would get, that nice stiff substance. And that's just a little bit more agitation. Very slight agitation gets us to whipped cream, and then we have 2 very yummy substances. So like I said, you can eat this when you're done, and it tastes really good.
You're forgetting the chocolate.
I'm forgetting the chocolate. Yeah, we could put a little chocolate, use the whipped cream. Right now I have 2 butter substances. I don't have whipped cream anymore, but I have really yummy butter here. The one note, if you do this at home, one, and always the very first rule is get mom and dad's permission first. Second, you are going to need the ingredient, which is just this. Today, this is all you need, and this is very simple to pick up at any local grocery store. Okay, heavy cream. Or you can go with the very simple version of it, just the whipped cream, whipping cream. And then all you need is a mixer. Okay, so if you have a hand mixer, one that you hold and it has the little rotating pieces, that works. Or the stand-up mixer like I have, that works. Or if you have a container and you can put some marbles in it or something to agitate, you can sit there and you can shake and you can have a really fun game of see who makes the butter first. But the bottom line of what I'm talking about today is that we took one substance and we put it through not one, but 2 separate chemical changes through the process of agitation. And you got 2 really yummy things. You got butter. Oh yeah, you can just do the cream. You got butter and you got whipped cream.
Hey, stay cool, stay fresh, and take your vitamins.